Welcome. This is AST 3114 Integrated Science Project, Project 2. The title of this project is Vitamin C Content in Fruits. First, introduction. What is vitamin C? The chemical structure of vitamin C is shown on the right-hand side of this slide. It has a chemical formula of C6H8O6. Vitamin C is an important nutrient to improve our immunity and stay healthy. If we get not enough vitamin C, it will cause scurvy to us. So, vitamin C is also known as ascorbic acid. It can be found in many fresh vegetables and fruits. Now, we need more vitamin C to protect ourselves against COVID-19, so we need to eat more foods with high vitamin C content. Now, let's talk about vitamin C content in foods. Vitamin C content in fruits can be affected by many factors, for example, food type, place of origin, cooking, prolonged storage, and exposure to light and oxygen. Lowering the level of vitamin C in fruits is essential to design nutritious meals. So, how to determine vitamin C content in fruits? Vitamin C reacts with iodine I2 by the following reaction. On the left-hand side, the reactants, vitamin C is colorless. It reacts with I2, which is brown in color, to form the products on the right-hand side. The products are all colorless. We can apply the above reactions to determine the vitamin C content in fruits. We can add iodine solutions to the fruit sample containing vitamin C drop by drop in the presence of starch indicator. When the solution turns blue, this means that all the vitamin C reacts with iodine to form the products. If we add more iodine solutions, this implies that more vitamin C is in the fruits. So we can conclude that vitamin C content is directly proportional to the number of drops of iodine. Here is an example. You may have heard about this. Vitamin C content of a gold kiwi fruit is nearly double that of a green kiwi fruit. Eat more. Is this true? You may browse some websites to find some information about the gold kiwi fruit. But are these websites reliable? For the websites which are relatively reliable, including governments, academic institutions, and public organizations. For the websites which are less reliable, including commercial organizations, because they may have conflicts of interest. Here is the objective of this project. Hypothesis 1. Gold kiwi fruit has a higher vitamin C content than green kiwi fruit. The independent variable of this hypothesis is the type of kiwi fruit, and the dependent variable is the vitamin C content or the number of drops of iodine. Resources. This is the list of chemicals, reagents, and materials used in the experiments. Please read it by yourself. And this is the list of apparatus and equipment used in the experiments. Please also read it by yourself. Now, let's talk about the procedures of this experiment. The procedures can be divided into two main parts. Part 1. Calibration of iodine solutions. The aim of this part is to find out how many milligrams of vitamin C react with 1 drop of iodine solution, which means that One drop of I2 equal to how many milligram of vitamin C? So, how to calibrate? Let's continue to talk about this. Now, let's talk about how to do the calibration process. We can use a vitamin C tablet to make a calibration solution with long amounts of vitamin C in it. Here is a photo shows a brand of vitamin C tablets. The label on the package says that each tablet contains 1000 mg vitamin C. When dissolve a tablet in 1000 ml of DI water to form a calibration solution, it contains 1000 mg vitamin C. Because 1000 ml calibration solutions contains 1000 mg vitamin C, so 10 ml calibration solution contains 10 mg vitamin C. Now let's continue to talk about the principle of the calibration process. The beaker on the left hand side contains 100 ml of DI water. When 10 ml of calibration solution and starch indicator are added into the DI water to become the beaker in the middle, the beaker in the middle contains 10 mg of vitamin C because we use 10 ml of calibration solution to make it, so it contains 10 mg of vitamin C. If we drop X drops of iodine into the solution and the solution turns blue, this means that X drops of iodine equal to 10 mg of vitamin C, and therefore 1 drop of iodine is equal to 10 over X milligram vitamin C. Here is the procedures for part 1. Step 1. Obtain a vitamin C tablet which contains 1000 mg vitamin C, and then make the calibration solution by dissolving the tablets in 1000 ml of DI water. Let's see a video. After the preparation of the calibration solution, let's continue. Step 3. Place a magnetic stirrer into a 250 ml beaker, and then add 100 ml DI water, 10 ml calibration solution, and 5 ml starch solution into the beaker. Let's see a video. And then add iodine solution drop by drop to the beaker with stirring by magnetic stirrer until the solution turns blue. Count and record the number of drops required. Let's see a video. Now, we finished the first calibration. In order to make the results to be more accurate, we will do 2 more calibrations. Let's repeat steps 3 to 5 2 times. Now, part 1 has been finished. Here, part 2, determination of vitamin C content in fruits. In this part, the aim is to find out how many milligrams of vitamin C per gram of food. And so, the unit of vitamin C content is milligram per gram. And then, how to determine? Let's continue. Now, let's continue to talk about how to determine vitamin C content in a food sample. As vitamin C is soluble in water, we can use 100 ml of dry water to extract nearly all the vitamin C from a food sample. Below is a picture. Firstly, there is set gram of food weighed out, and then we use 100 ml of dry water to extract nearly all the vitamin C into a beaker, and starch indicator is also added into the beaker to become the beaker in the middle. The beaker in the middle contains a known amount of vitamin C, and then we add iodine into the beaker. If white drops of iodine are added into the beaker to make the solution to become blue, this means that there is 10 over x times y milligram of vitamin C in the beaker, and then divide this value by Z, we can find the vitamin C content. Here is the procedures for part 2. The first step, peel and cut a gold kiwi fruit into small pieces, and then weigh out about 10 grams of the gold kiwi fruit into a mortar and record the exact mass. Let's see a video. Step 3. We need to place a magnetic stir bar into our 250 ml beaker, and then use 100 ml dry water to extract the vitamin C from the gold kiwi fruit into the beaker with the aid of mortar, pestle, funnel, and gauze. And step 5. Add 5 ml of starch solution into the beaker. Let's see a video. After the preparation of the extraction of gold kiwi fruits, we need to add iodine solution drop by drop to the beaker with stirring by magnetic stirrer until the solution turns blue. Count and record the number of drops required. Let's see a video. After the first determination of vitamin C content in gold kiwi fruits, in order to make it to be more accurate, we need to do 2 more determinations. So, we repeat steps 2 to 6 2 times. And then, we repeat the above steps by replacing gold kiwi fruits with green kiwi fruits. In the reports, students should write the procedures in past passive voice and paragraph form. Please remember. Here shows the results of Part 1 calibration of iodine solution. This table shows the number of drops of iodine used in Trial 1, Trial 2, and Trial 3. And you need to calculate the average number of drops of iodine used, and then calculate how many milligrams of vitamin C react with 1 drop of iodine. Here is the result of Part 2, determination of vitamin C contents in fruits. And this line shows the results of gold kiwi fruits. The table shows that the first row is the mass of fruit sample used in each time, and the second row shows that the number of drops of iodine used in each time. You need to calculate the vitamin C contents in milligram per gram in gold kiwi fruits. Here is the result of green kiwi fruits. You need to use the same method to calculate the vitamin C contents in green kiwi fruits. After the calculation, you need to plot the chart showing the vitamin C contents in different kiwi fruits. You need to judge by yourself of using bar chart or line chart. Now let's talk about discussion. In this part, it can be divided into 4 main parts. The first part is analysis of data and results. In this part, you need to analyze the data and results and then judge whether the experimental results support the hypothesis. The second part, rationalization of results. You need to use some theory to explain why you get these results. And then, error analysis or drawbacks of the experiments. I can give you a hint that do you think Each drop of iodine has an equal volume. And the last part, suggestion for improvement. You may use B-RAT to improve the experiment. Risk assessment. In this part, you need to list out some potential hazards of the experiment and the corresponding safety measures. Conclusion. In this part, you need to write down the hypothesis of this project is supported or rejected by the experimental results. References. Below is the list of the references used in these projects. The end. Thank you.